Welcome to our session on modeling information systems using use case diagrams. These diagrams are essential for visualizing the functional requirements of a system, providing a clear picture of how users interact with the system to achieve specific goals. Use case diagrams help identify the key actors, their roles, and the actions they perform within the system. They simplify complex processes, making it easier to understand what the system needs to accomplish from the user's perspective. By focusing on interactions and functionality, use case diagrams bridge the gap between user needs and system design, ensuring that all requirements are clearly defined and well documented. Here, we see the mapping to the relational schema. This diagram illustrates the relationships between different entities in a system, such as companies, clients, and events. This, as discussed during the previous lesson, is part of data modeling. Use case diagrams are a fundamental part of the Unified Modeling Language, or UML. They visually represent how users, referred to as actors, interact with a system. These diagrams focus on what the system does, rather than how it does it, offering a clear, high-level view of its functionality. They help identify the different types of users and the specific actions they perform within the system. For example, in a library management system, a use case diagram might show how a librarian checks out books or how a customer searches for a title. By breaking down complex systems into simple, understandable interactions, use case diagrams ensure that both technical teams and stakeholders have a shared understanding of the system's scope and purpose. They are an essential tool for bridging the gap between user requirements and system design. Use cases describe the functionality of a system from a user's perspective. They depict behavior, show relationships, document scope, and illustrate understanding of user requirements. Use case models are developed at various levels of abstraction and are part of an iterative and incremental process. They include class, activity, sequence, and state chart diagrams. A use case is a set of interactions between a user and a system. Key components include actors, use cases, system boundaries, and relationships as denoted here. Take note of the notation, shapes. Use cases capture detailed information that is critical for understanding and designing a system. Let's break down each element. Actors represent the users or other systems that interact with the system being modeled. These could be human users, external systems, or devices that communicate with the system. Relationships describe how actors and use cases are connected. For example, a customer might be related to a use case for placing an order, while an administrator might manage system configurations. Preconditions specify the state of the system or the environment that must be true before a use case can be executed. For instance, a user must be logged in before accessing their profile. Post-conditions define the state of the system after the use case has been completed. These ensure that the expected outcome of the use case is clearly defined, such as confirming a successful transaction. Exceptions identify scenarios where the normal flow of events is interrupted, such as when a payment fails during an online purchase. These are crucial for handling errors and other occurrences. Constraints outline the rules or limitations that must be adhered to during the execution of the use case. This could include security requirements or performance thresholds. Alternatives capture variations in the use case flow. These describe different ways the same goal can be achieved, such as providing multiple payment options during a checkout process. By capturing these elements, use cases provide a comprehensive view of the system's functional requirements, helping to ensure that the system is designed to meet user needs effectively and reliably. An actor, as represented in the notation drawings, interacts with the system under development. Actors can be human or automated systems and are not part of the system itself. Actors play roles with respect to the system and can perform multiple use cases. Their roles are determined by observing direct system use. Primary actors are the main users or entities that interact directly with the system to achieve their specific goals. They initiate the use case and are the focus of the system's functionality. For example, in an online shopping system, a customer placing an order would be a primary actor. Secondary actors, on the other hand, are not directly interacting with the system, but are invoked by the system to support the primary actor's goals. These actors provide auxiliary services that ensure the use case is successfully completed. For instance, a payment gateway processing a transaction or a shipping service updating delivery status would be considered secondary actors. Together, primary and secondary actors work to fulfill the functional requirements of the system, ensuring that all interactions necessary to achieve the desired outcomes are addressed. A use case is a pattern of behavior that the system exhibits. It represents a sequence of actions taken by a user to achieve a specific goal. Use cases represent complete functionality of a system, covering the entire process from start to finish. They detail all the steps involved, ensuring that every interaction needed to achieve a specific goal is documented. For instance, a use case for an online purchase would include steps like selecting items, adding them to the cart, making a payment, and receiving confirmation. These use cases are typically generated during the initial phase of system development, as they help define the functional requirements and provide a foundation for system design. However, they are not set in stone. As the project evolves and new requirements emerge, additional use cases can be created, or existing ones can be updated to reflect changes. This flexibility ensures that the system remains aligned with user needs and project objectives throughout the development process. In use case diagrams, the system boundary is represented by a rectangle that encloses all the use cases. This boundary clearly defines what is internal to the system, essentially the functionality the system provides, and what lies outside, such as external actors or systems interacting with it. By outlining the system boundary, we can differentiate between the roles and responsibilities of the system itself and those of external entities. For example, in a library management system, processes like cataloging books and issuing loans would fall inside the boundary, while users like librarians and members interacting with the system would be outside. The system boundary is a critical element for ensuring that the scope of the system is well defined, preventing confusion about what is included in the system's functionality and what is handled externally. Relationships in use case diagrams include associations, extends, generalizations, uses, and includes. These relationships define how use cases interact with each other. We will look at them in the next series of slides. The extend relationship in use case diagrams is used to indicate that one use case optionally includes the behavior of another use case at specific points in its flow. This relationship allows for additional functionality to be added to a base use case without altering its main purpose. It is represented with a dotted line and an arrow pointing from the extending use case to the base use case. For example, in an online shopping system, a place order use case might have an extension for apply discount code that is invoked only if the user chooses to enter a discount code. The extend relationship is useful for handling optional or conditional behavior, ensuring that the main use case remains focused and streamlined while still allowing for flexibility to accommodate additional scenarios. Generalization in use case diagrams applies to both use cases and actors. For use cases, a general use case is extended by more specific ones, inheriting common behavior with added details. For example, a general borrow item use case can be specialized into borrow book and borrow DVD. This is shown with a solid line and a hollow arrow. Similarly, actors can be generalized, where a common actor is extended by more specific roles. For instance, a user actor can be specialized into student and instructor, both sharing common actions like logging in, but with distinct responsibilities. Both relationships help simplify the diagram by reducing redundancy and promoting clarity. The uses relationship in use case diagram shows when one use case utilizes the functionality of another use case. This means that the behavior of one use case is incorporated into another, helping to avoid repetition and ensuring reusability. It is depicted with a solid line and a hollow arrow, with the keyword uses indicating the relationship. For example, in an online shopping system, the checkout use case might use the validate payment use case, meaning the checkout process depends on the validate payment process being executed first. This relationship helps modularize the system by allowing use cases to rely on shared functionality, promoting a cleaner and more organized system design. The include relationship in use case diagrams allows one use case to insert additional behavior into a base use case. This relationship is used when a use case always includes the behavior of another use case as part of its process, ensuring that certain steps are always executed. It is depicted with a dotted line and an open arrow, with the keyword include indicating the relationship. For example, in an online shopping system, the place order use case might include the verify inventory use case, ensuring that inventory is checked every time an order is placed. This relationship helps break down complex use cases into smaller, reusable components, promoting modular design and reducing redundancy in the system. In this diagram, we can see the difference between the extend and include relationships in use case diagrams. First, let's talk about the extend relationship. In the diagram, we see that perform security check is an extended use case for enroll in university. The extend relationship indicates that the security check is an optional behavior only invoked under certain conditions, such as when an international student is enrolling. The dashed line and extend label show that this behavior is added to the base use case in specific situations, not every time. Now, let's look at the include relationship. Enroll in seminar is included in the enroll in university use case. This means that enrolling in a seminar is a required step whenever a student enrolls in the university. The include relationship, shown with a dotted line, indicates that this behavior is always part of the enroll in university process. It's a mandatory inclusion that happens every time. By understanding these relationships, we can see how extend and include help structure use cases based on whether certain behaviors are optional or always required. A use case description includes key elements that provide a detailed overview of the system's functionality. Title: the name of the use case. Author: the person or team who created it. Purpose: the goal or objective of the use case. Actors: the users or systems interacting with the system. Preconditions: conditions that must be true before the use case starts. Post-conditions: expected outcomes once the use case completes. Exceptions: error conditions or deviations during execution. Constraints: limitations or restrictions on the use case. Alternatives: different scenarios or paths that could be followed. These components help ensure that the system's requirements and behaviors are clearly defined and understood by both developers and stakeholders. Let's consider an example use case for withdrawing money from an ATM. This use case outlines the steps and conditions required for a successful transaction, including user interactions and system validations. The actors involved in this use case include the customer and the ATM system. Preconditions must be met, such as the ATM being ready to accept transactions and having sufficient cash and paper for receipts. The typical course of events for this use case begins when a customer arrives at the ATM and ends with the customer taking the cash and receipt. Each step involves specific actions by both the customer and the system. Alternative and exceptional flows, also known as secondary scenarios, address scenarios where the transaction cannot proceed as usual. These include authorization failures, insufficient funds, and power failures, ensuring the system handles all possible outcomes. One method to identify use cases is actor-based. This involves identifying actors related to the system and understanding their interactions and requirements, helping to define the use cases effectively. Thank you for your attention. This concludes our presentation on use case diagrams and their importance in system design.